So here are a few quick examples of finding limits of different types of functions. So the first one, limit of cosine of 2x as x approaches pi over 2. This is the same as cosine of, we move the limit in, because cosine function is continuous, move the limit in. So that's limit as x approaches pi over 2 of 2x. Now what's the first technique that we need to try when we have to find limits? Notice this is a polynomial function. So substitution works. So substitute x equals pi over 2. So this is equal to cosine of, cancel the 2's, it's cosine of pi. Now, if you're confused or if you don't remember what cosine of pi is, just enter it into your calculator and you'll notice that's equal to -1. Make sure that the settings on your calculator are for the radian measure, not the degree measure. Now the next one, you can either substitute x equals pi over 4, enter it into your calculator and you get your answer. Or if you remember the Pythagorean identities, 1 plus tan squared x is equal to secant squared of x. So that when substituted we get 1 plus tan squared x is secant squared of x divided by secant squared of x. Even before we substitute, we get 1. Limit of 1. 1 is a constant. No matter what happens to x, the answer is always going to be 1. And even if you substituted pi over 4 into this equation and used your calculator, you would still get 1. The next example, we do the same thing. We move the limit into the radical sign. So that is limit as x approaches 1. We apply the limit to the inner function, x cubed plus 4x minus 1. Now that's a polynomial function. So all we have to do is substitute. When we substitute, we get 1 cubed plus 4 times 1 minus 1, which is equal to 4. Now here we have some examples with exponential functions. The first thing that we always try is substitution. If substitution doesn't work, that's when we try other techniques. So let's try substitution. So it's e to the 3 times 0 plus 2. 3 times 0 is 0. So that's e squared. That's all there is to it. If substitution works, that's your answer. Don't enter it into your calculator, because when you enter e or any expression related to e into your calculator, you only get an approximation. So if your answer is in terms of e, just leave it that way. That is the exact answer. Any other form would be an approximation. Now same thing here, just plug it in. So e to the -1 the whole squared over 2 minus 1. So that would equal e to the -1 squared is 1 over 2 minus 1. So that's e to the -half. That's the exact answer. You could also write it as 1 over e to the plus half, and remember the exponent half is the same as radical e. So any of these, that's a right answer, that's a right answer as well, and that's also a different way in which you could write your final answer. Now the next one, first thing, remember, we always substitute. So when we substitute, we get e to the 0 minus e to the 0, e to the 0 minus 1. So e to the 0, remember, is equal to 1. Any non-zero base to this power of 0 is equal to 1. So that's 1 minus 1 divided by 1 minus 1. So that is a 0 over 0. So remember that when it's a 0 over 0, you don't give up, but you try other techniques to see if you can find the limit. So let's see if we can do something about this expression. So we have limit as x approaches 0. Remember that e to the negative x is the same as 1 over e to the negative becomes positive when you move a number from the numerator to the denominator. The sign of the exponent changes. So we have 1 over, so we are starting from here. So e to the negative x is 1 over e to the x minus e to the x over 1 over e to the x minus 1. So the numerator is that, and this is the denominator. Now let's look at the numerator. Let's take a common denominator, which means we need to multiply the second number by e to the x and divide by e to the x. Here we need to multiply by e to the x, divide by e to the x. That's how we get a common denominator of e to the x. So that is equal to, now we're looking at the numerator. Okay, so that's our numerator. The common denominator is e to the x minus, over, the numerator is 1 minus e to the x times e to the x, the whole divided by, so that's, we're done with our numerator. And now we're looking at our denominator. Again, the common denominator is e to the x. We have 1 minus e to the x. Okay, so now this is the same as, so remember this is division. So we have 1 minus e to the x times e to the x over e to the x divided by 1 minus e to the x over e to the x. Which is the same as 1 minus e to the x times e to the x. The division becomes multiplication. So we flip the fraction here. So that's e to the x over 1 minus e to the x. And here we have 1 minus e to the x times e to the x over e to the x. So now we're ready to cancel these two. So we could have done that here as well, but I just wanted to show you why that cancels. And now we're left with 1 minus e to the x times e to the x over 1 minus e to the x. Now we're ready to take the limit again. So let's write down limit as x approaches 0. Limit as x approaches 0, limit as x approaches 0, and now we are ready to substitute limits again. Since we have made some cancellations, now let's see if substituting limits will help. So we have 1 minus e to the 0 times e to the 0. Remember, x is equal to 0 when we substitute the limit. So we have e to the 0. So that's 1 minus (1 over 1 minus 1). So we still have the same problem, which is 0 over 0. So let's look at this expression again. So limit as x approaches 0, let's write this e to the x times e to the x as e to the 2x. So that's 1 minus e to the 2x over 1 minus e to the x. Since substitution didn't work, we're trying something more. So this is equal to 1 minus e to the x. So we write this as e to the x the whole squared. So e to the 2x can be written as e to the x times 2, which is the same as e to the x the whole squared. So that is 1 squared minus e to the x whole squared is 1 minus e to the x, 1 plus e to the x divided by 1 minus e to the x. And finally, we're able to cancel the factor that's causing the 0 in the numerator and denominator. Once we do that, now we can substitute once again. X approaches 0, 1 plus e to the x, which is equal to 1 plus e to the 0, which is 1 plus 1, which is equal to 2.